Today we'll be talking about kinetic energy and gravitational energy and how to actually do math with those things. So we talked about it earlier in Unit 2, where they come from, what they mean, but we will now start to do a little math with them. So first up, a recap of kinetic energy. Kinetic energy is just the energy of motion. So remember that when objects are moving, they have kinetic energy. We have a couple different parts of an equation to calculate kinetic energy. So let's say we see EK, that is the symbol for kinetic energy. So we've used this already in Unit 2, but now we'll come back to it. EK is kinetic energy. It gets an equation, so like let's say we're trying to find out the kinetic energy of an object. Its equation is 1/2 times the object's mass times its velocity squared. So this is the equation to calculate EK. The units of kinetic energy are joules. So it's just a big J, or a capital J is the unit for energy, joules. If we want to solve for mass, so let's say we know the kinetic energy of something and its velocity and we want to find its mass, M just stands for mass. And then if we do a little algebra to this equation, the version that lets us solve for mass is just 2 times however much kinetic energy it has divided by its velocity squared. And the units for mass when we use this equation will be in kilograms. And then lastly, velocity is v. It gets the equation, again, if we do a little algebra, if we want to solve for v, it is the square root of 2 times the kinetic energy divided by the mass. And the units of velocity are meters per second. When we look in a problem, if it asks for kinetic energy, usually it'll just say the words, what is the kinetic energy? Same for mass, what is the mass of the object? But frequently, when it's looking for velocity, since that one's a little more common, it might just say how fast is the object moving, and that's implied to mean the velocity. So you can fill in this chart in your notes. You can pause the video here if you need to, finish filling this in, but then we'll move on to gravitational energy. Gravitational energy, remember, is the energy stored in because of an object's height. So depending on how high it is off the ground, that's how much gravitational potential energy it has. So if they are above the ground, they have some gravitational potential energy. The equation to calculate gravitational potential energy, which is abbreviated EG, is just right here. It's mass times G times H. So G is a constant, and it just stands for 9.8. So that has to do with basically the strength of gravity on Earth. If you were to go to a different planet, or like the moon, for example, the moon, G on the moon is 1.6. If you go to Jupiter, it's like 30. So just for Earth, the constant is 9.8, and pretty much all the problems we do will be on Earth. So just anytime you see G, think of it's just a short way to write 9.8. So instead of writing out 9.8 every time, we just write out G, but it means 9.8. So anytime you see it, just 9.8. And then H is the height. So M times G times H. Again, gravitational energy, it gets units of joules. So that's capital J. If we want to solve this equation for mass, so if we're looking for the mass of an object, it is just the gravitational energy divided by G times H. And the units of mass are still kilograms. And then H just stands for height. If we solve the equation for H, height is equal to EG over M times G. And the units for height are meters. So again, be careful here. This is meters as a unit, and this M over here stands for mass. So when you look in an equation, if you see M in the equation in any of these, that means mass. And then at the end, like let's say our answer is 4 for height, that would be 4 meters. So if it comes after a number and it's not in the equation, then that just represents the units. And remember, that's short for meters. Like the last one with kinetic energy, if we're looking for gravitational energy, it'll just say the words gravitational energy, or what is the gravitational energy. Mass, it'll say what is the mass. Height, that one is common enough that we might just say how high is the object, and that just means what is its height off the ground. So if you see how high, that's really just asking for height. So now we'll do a couple examples. Again, you can pause this here if you need to finish filling in this table. But now we'll look at a couple examples. So if we want to calculate how much kinetic energy an object has, we need to pick out the right equation. So here we see we have a 1,200 kilogram car. This is where knowing units are helpful. So kilograms, that's a mass, traveling at 35 meters per second. Meters per second, that's a velocity. So we have a mass here and a velocity. and it's asking us how much kinetic energy does it have. So we want to pick the equation that solves for kinetic energy, so that's this first one here. So we just say EK equals 1/2 or 0.5 mass times velocity squared. And if we substitute our values in, 0.5 stays, we plug 1200 in for mass, and then the velocity is 35 right here. Again, units are helpful, so kilograms is mass, meters per second is velocity, so we just plug this in, and then we can use a calculator from here, multiply it all together, and we get 735,000 joules. In the next example, here we're asking, we have a 0.5 kilogram basketball shot with a velocity of 10 meters per second. How much kinetic energy does it have? So again, look at our units. Kilograms, that's a mass. Meters per second, that's a velocity. And it's asking how much kinetic energy. So we use the same equation again. Kinetic energy right here. We can plug our values in. EK equals 1/2 times 0.5 for the mass, 0.5 kilograms, and then 10 meters per second for our velocity. Same thing, multiply it all out in a calculator, and we get 25 joules for our answer. So once again, remember, units for energy are joules. If we look at the gravitational energy equation, here we have a 0.025 kilogram marble. It's on the top of a ramp that is 0.2 meters off the ground when it's at the top of the ramp. And then how much gravitational potential energy does it have? So we want the equation that solves for gravitational potential energy right here. So there it is. We can substitute our numbers in. So mass, again, look at the units. 0.025 kilograms tells us it's a mass. G, remember in this equation, G is always just 9.8. It's just a short way of writing 9.8. So if you see G in an equation, it means 9.8. So we just plug it in there. And then H is the height. We get that 0.20 meters. Meters lets us know it is a height. So we multiply all of these together. This one is a pretty small answer, but it's 0.049 joules. The last one here, we have a 5 kilogram book that has 750 joules of gravitational potential energy, and it's asking what is the height of the book off the ground to have this much gravitational energy. So this time, since it's asking what is the height, we want to use the equation that solves for height. So that's this version right here. So height equals gravitational energy over mass times g. So that's the equation we're using. And when we substitute our values in, we get our gravitational energy. Again, look at units. J means joules. That means energy. Those are the units for energy. So that's what goes in for EG on top. And then on the bottom, mass is 5. Again, look at units, kilograms. And then G is always just 9.8. Be careful with your order of operations here. If you're typing this into a calculator and you just type in 750 divided by 5 times 9.8, you might not do it correctly. So in a calculator, put the whole denominator here, the whole bottom, in parentheses if you're doing it in one step, or just take 5 times 9.8 and then 750 divided by that number. So when we do that, if we solve it correctly, we would get 15.3 meters. Again, meters, units for height.